Good day, my name is Randy Armstrong, and I'm here to talk to you about developing OPC UA pub/sub applications based on the IIoT Starterkit, which is an initiative which the OPC Foundation has been working on, and it provides a number of samples and tutorials to allow coders to develop prototypes and explore the capabilities of OPC UA pub/sub over MQTT. We are focusing on MQTT because there's been a lot of interest in the marketplace. There's a lot of people looking at MQTT. They see it as something that has potential to solve some of the problems they're trying to solve. And we wanted to sort of dispel the huge amount of misinformation that's been spread about OPC UA. Specifically, OPC UA pub/sub and MQTT have been part of the OPC UA specification for a number of years now. Vendors are starting to release their products that support it, and this will continue to happen over the next couple of years. So the statements that have been made that somehow you have to make a choice between using MQTT and OPC UA are simply put false. The capabilities that if you want to use MQTT, there are mechanisms within the specification to allow you to use it. And what I'll be demonstrating today and talking about today is how you can take advantage of these features. Now, it is worth having some higher level discussions about what UA pub/sub is and how it relates to UA client server. Now, client server is the workhorse of computing applications. It's almost every application out there is doing some sort of client server operation. And with a client server situation, the client knows about the server. The server has a dedicated channel back to every client. The client sends a request, it gets a response. It's a tightly coupled relationship. And this has advantages, but it also has disadvantages. In a pub/sub model, what you have is you have a bunch of publishers that are sending out messages to some sort of middleware, of which MQTT is one example. The subscribers are listing on that middleware, on an address on the middleware, and they're getting messages from the middleware without really knowing where the subscribers are, or where the publishers are. So you have a situation where your publishers and subscribers are completely decoupled. They don't even need to be online at the same time, depending on how if your middleware supports some sort of message persistence. So this is a useful message paradigm if you have a situation where you need to be sending the same data to a large number of recipients, or if you need to be sending data to recipients that aren't necessarily online or don't care about. Basically, it's a send and forget operation. You don't want to have two-way communication, or you don't need to have two-way orchestration. And this does not mean that the need for client server goes away. Client server itself solves some other problems very well. Anytime you have a client doing an operation where their ability to proceed with the next step depends on the response from the server, then you want to have the tight coupling, because that's the only way you're going to get the latencies that you need to make that application usable. So with OPC UA, our vision is not to say that you have to sort of buy into using pub/sub or buy into using client server. No, we're providing a cohesive framework where you have a number of tools that you could deploy to solve different problems within your factory environment based on which tools are the best tool for the job. So when you're doing your configuration and your setup, well, you're going to be using UA client server. If you've got a situation where you could want to set up your runtime environment and you think it's helpful to use a broker for communication at that point in time. You could then configure your publishers and subscribers using client server, and then your runtime environment will be entirely based on PubSub. So it enhances the capabilities of OPC UA. So there's a certain amount of value of using MQTT with OPC UA. And one of the most important things is it's an abstraction layer that does not depend on the protocol. It's an architecture that works over any kind of middleware. And in fact, it's designed to work with UDP multicast and the entire UFA FX effort that's going on down with the controller-to-controller communication, which the OPC Foundation is working on right now, is all based on UA PubSub using the same configuration mechanisms, the same kind of encodings. All of the infrastructure that's being built to support that is also available to support application developers building with MQTT. And this framework also includes support for binary encoding, it's support for JSON encodings, and potentially other encodings down the road. End-to-end security, there's mechanisms in place to allow you to send a message and not worry about whether or not you trust the middleware. The standard configuration information model, I'll be talking more about that later in this talk. That's a very important feature. And integration with OPC UA information models. Now, the idea that PubSub works with any middleware is a future-proofing capability that allows you to evolve over time. So I've been around long enough that I know when people were talking about how XML web services were the future of computing, distributed computing, and you had to be crazy if you didn't build stuff using XML web services. Well, guess what? XML web services lasted maybe 5, maybe 10 years. Now nobody talks about them. Nobody's really even talking about XML as a wire protocol anymore. Because technology evolves, requirements change. The technology that was awesome today turns out to be lacking in the future. OPC UA gives you an architecture that can evolve as needs change. The other important part has to do with the information models. Now, it's no longer acceptable just to send out your raw data to whoever's receiving it and expect them to try and figure out what to do with it. There's a need to describe this data with the context so you can properly understand what this data is and properly operate on it. So it's important to provide information models or develop information models that describe this information in standard ways. And OPC UA has numerous information models. It's got the built-in ones. It's also got a number of other standards bodies developing information models for different verticals, from robots to PLCs to kitchen equipment to pumps to pharmaceutical industry. There's numerous information models that are available. And you get all of these things if you're using the OPC UA infrastructure. And this is important because when you're trying to get your data into the cloud-based applications, they want to operate on well-known information models too, because it allows them to incorporate data from multiple sources much more efficiently. They don't want to have data coming in some custom format from one factory in a different format in another that has to be mapped onto a standard representation. They want to see that data coming through in the standard representation that it had in the original device. OPC UA over MQTT does that for you. Now, the starter kit itself is intended for people who love to tinker. It's been tested on a Raspberry 4, Raspberry Pi 4 with GPIO ports. If you don't have GPIO ports, it runs fine on a VM. It will flip over to a simulation mode. It includes a publisher and a subscriber. And I'll be demonstrating these here. Everything in this particular version, everything's been developed in .NET, but plan is we'll try to expand that to other computing languages as well as time goes on. The code is all available on GitHub, and any comments or feedback or questions you have about the presentation today, please feel free to start a conversation on the comment section on the GitHub site. So with PubSub, you got to start with a publisher. So we have a publisher that starts a UA server that has a pluggable GPIO mechanism that could map GPIO ports onto an information model. And you can browse this server using any standard UA client. The publisher itself is a UA client that collects the data from the server, bundles up the messages, and sends them out to the broker. Now, because of the nature of PubSub, all publishers need to be pre-configured. So to sort of simulate this situation, the configuration of the publishers are in the dataset and the connection JSON files. These two files the contents of these two files are completely defined by the OPC UA specification. It's all part of Part 14. And there's a binary and a JSON version of it, which is probably not relevant for our examples, but the JSON version is what's being used in the sample. Now, these standard files are a key part of the value proposition for OPC UA over MQTT, because the working group realized that just putting together a wire protocol and sending data over a broker doesn't really solve the problem, because you need to have a standard way to configure all of these different devices that you're putting together. That it's easy to throw together a sample where you're collecting data from a GPIO port and constructing a JSON message and fire it off. But if you've got 1,000 devices and you got to configure every one of them, that becomes a huge time-consuming task. OPC UA solves this problem by providing standard configuration files and an information model that could be accessed via UA server. So if this UA server supported the PubSub information model, you would be able to have a UA client come in and edit the PubSub configuration. And this allows you to remotely manage all of your publishers on the network from a single application. And that's something you're not going to get without the cohesive OPC UA framework. Now, the information model, for this particular example, we wanted to keep it simple. It is a single GPIO pin connected to an LED that using as a simulator for a conveyor belt gate. It has a state and a cycle time. The state itself has true labels and false labels. Then you have EU range and engineering units on the cycle time. But this is an example, simple example of an information model. If we had a more complex system, such as a robot, you would have a more complicated set of variables, and they would have interrelationships and different sets of properties that would be potentially useful or important for any consumer of the data to understand. The subscriber itself interacts only with the MQTT broker, the topic tree in the MQTT broker. The topic tree that the samples use is based on the configuration file format. If you go and you dig into the configuration file format, you'll find a hierarchy of named items. Well, that's the hierarchy that ends up being the topic tree. So we have a we have the publisher ID. We have sort of a middle tier that specifies how it controls the details that go into the messages, and then you have a level that describes the object that's being published. The same object's being published in two different topics, and I'll explain why we're doing that in the demos. Is just to illustrate different features of the OPC UA specification. And underneath the data sets, which is the gate 1 and gate 2, you have the metadata. And this metadata is key for being able to get the information model that is needed to understand the data. So the first demo I'm going to do is I'm going to do some basic publishing with the Raspberry Pi. So I'm going to start the I'm starting it on the Raspberry Pi, and the server is running. I will open up the standard UA client. It should connect. There we go. And as you see, we're getting the data changing every 10 seconds because that's what the cycle time is. Now, it's important to note that with UA pub sub messages, only changed data is published. So in these demos, the data is being sampled the update rates are coming in could be coming in as fast as once per second, but since the cycle time is 10 seconds, we're only getting a message published once every 10 seconds. So this is an important efficiency feature. So we also see a bunch of information has been published to the broker. I'll talk about some of the other ones, but I want to focus on this particular message here. This is the bare minimum message that gets sent out. One of the features of OPC UA pub sub is you have complete control over what goes into the messages. So if you have a huge number of devices and you don't see the need for a lot of metadata in your messages, you can strip them down to minimize the network overhead and only send that information. And when this is converted into a binary format, it gets really compact. This would probably be less than 10 bytes in size. And this is an important feature that they're using for the UAFX effort, where they expect to be able to develop hardware which is capable of producing and consuming UA pub sub messages. Now, if you have other types of subscriber applications that are more dynamic, they want to be able to collect data from many different sources, and they don't necessarily want know in advance what they're getting, and they want to be able to process it based on what's in the messages. There's a bunch of other information that could be included, including stuff such as a dataset class ID that tells you that it allows you to correlate messages that have the same structure, even if they're sent from different devices. You can also have a sequence number, a timestamp, as well as a publisher ID. In this case, it's Raspberry 01. So subscribers generally are disconnected from the publishers, but sometimes you have a subscriber wants to know what's out there. So we can take advantage of wildcard wildcarding capabilities within MQTT and create a subscriber that can detect whenever a new device is on the network. And that's going to be the first demo we'll do here. There we go. Starting the discovery agent. Starting the server. And you see this message appears. And so this message itself, it is a vendor, it's called a vendor nameplate. The information model is defined by the OPC UA devices specification, which in there, you go in there, you'll have complete definitions for each one of these things, what it is, what's expected to be there. In particular, the product instance URI is intended to be a globally unique identifier for the device. In this case, I'm just passing an identifier I provided to the publisher when it started up. But this could be the maker of the device, their domain name. It could be any other piece of information that's necessary to keep it globally unique. Now, this is actually a very important piece of information if you're pushing data up into the cloud, where they need to have some unique identifier to separate data coming from all these different sources. They want to be able to correlate this data and say, okay, this particular data is coming from this, and this is the identifier for it. And so OPC UA has a standard for creating these identifiers and publishing them along with associated other metadata. For the next demo, we want to actually take a look at the data that you're getting. Now, in this example, the subscriber knows the data set that it's getting in advance because it's been copied onto the device. So it uses this data set to interpret the information that it's getting back. However, this is not required. These are all JSON messages. So you could have a generic JSON, or you can have a generic client that processes JSON and can still do useful information with it. But what we're getting here is because we've got the data set, it knows that this particular cycle count is a uint32, which separates it from all the other possible numeric values that could show up, could be mapped onto a number field in a JSON document. Now, the last demo is subscribing to metadata. And this is the key part where we're tying all of this stuff back into the information models that OPC UA provides. So, as I mentioned a number of times before, there's a special topic for metadata. So I now started a client that subscribes to that topic, and we're getting the same information in the metadata, including some descriptive information that's come from the metadata. So let's go back to the raw message and take a look at let's see, you've got the fields that show up, but most importantly, you've got these properties, and these properties come from the information model. If you remember before, there was a true state and a false state. Well, the true state and the false state are the properties on the object, and in this case, they happen to have the value open and close. So the metadata allows you to bundle a whole bunch of additional information with every data point that you're that you're providing. And this information has names which are defined by standard OPC UA information models. So you don't need to deal with the problem that, yeah, sure, you've got a message from one device that had a discrete value that used one label for its true and false state, and another device used a different label for its true and false state. And then somehow your subscribers have to make sense of these different things. UA standardizes all that and a lot more. And you cannot underestimate the value of simply doing something as simple as picking a name and getting everybody to use it. And of course, when you start to get into more complicated information models, dealing with complex equipment such as robots or kitchen equipment, there would be a bunch of potentially additional properties which would be interested to those types of applications that deal with that kind of equipment. So that concludes the short demo of the starter kit. I hope you found the discussion useful today and gave you some ideas in terms of how you can take advantage of OPC UA Pub Sub. As I mentioned before, the code is all available on the OPC Foundation GitHub, along with all the documentation, including complete details on how to set everything up and get started. And any questions, of course, please simply post on that forum. Thank you very much for your time and have a good day.